So, can a DC power bank do 120 watts of power? It sure can. This power bank has been 3D printed. The design will be shared, and you can also build this at your home. It's very easy. The circuit is very simple, and I feel it looks okay also. So, I will show you it drawing 120 watts. You can see. So now let me show you what all parts you need. So also I will be giving the Indian and the international links for all of the parts which I will be showing, so that you can make the same power bank if you wish to. So first, what comes is the 120 watt USB PD two-way fast charging module. So this is what allows us to get the PD protocol on our power bank, and it can deliver up to 120 watts. So it's a pretty powerful board. This is the DALI 4S battery management system. So this will be monitoring our battery pack, whether all the voltages across the four cells is the same, whether it's not getting overcharged, over discharged. So this is also a very important part of a power bank. So as you can see, they have also given a connection diagram. I will be explaining all the connections myself, but if you want, you can refer this image also if you are somewhere confused on how the connection of the BMS and the battery pack works. Next is the lithium ion cell which we have selected. So it is a LG 18650 cell. It is rated for a capacity of 3400 mAh at a 3C discharge rate. So next is the 18650 battery holder. As I don't have a spot welder, and I think most of you watching will also probably not have one, so to make the assembly simple, and also this enables our batteries to be hot swap. I have not found any concerns in using this. They have always performed up to the mark. There is no like battery like current draw limitations I have experienced using these kind of holders, so I feel it's pretty good. Also, one mistake you definitely should avoid: you should not be directly soldering onto the lithium cells to connect them in a battery, to make them into a battery pack, as that can damage the cell itself. So avoid that and use this kind of a holder. Next is the 4S 18650 lithium battery capacity indicator. So it's a pretty simple circuit. So there are four LEDs which will light up according to how much charge your battery pack has. There is also this push type switch. So this indicator will only show the battery level when you are pressing and holding the switch. So it will not just stay on forever and drain the battery pack. So that's a pretty neat feature which is built into the circuit board. Next is the switch which we will be using. So as you can see, it's a single pole push button kind of switch. So it has four connections on the back. So two of them would be connecting to the battery pack for cutting the power, and two of these are for the LED on the front. So there would be a blue LED here. Heat sinks which are actually made for Raspberry Pi, but I was able to use them on this board also. So you will be able to see in the final product, I have pasted this copper one on the top of the large inductor on the PD board, and these two fin type ones are go on the bottom of the board. You just Next are these M3 size brass inserts. I will be using them and a soldering iron, and I will press them into the holes I have made on the power bank casing. So because the lid is going to be screwed close on the power bank. The design which I am giving for free, that will have accommodation for this M3 knurled nuts. Next is finally the screw I'm going to use. So we will use these M3 size screws. We will use 6 of them. We have used this 8 size nuts in this project. So I have already designed the power bank case. In this video, I will not be showing how you will be able to design one yourself. That can be a separate video because it will be very long. So as you can see, it has two parts: the top part and the bottom part. So if we hide the top part, you can see inside. This is where the PD board will sit. This hole is for the switch. This empty area will accommodate our BMS. This bigger cavity will accommodate the cells. and this side wall with the holes will accommodate the battery indicator. So there are 6 holes for screwing the lid, as you can see. So here, this is where you are supposed to heat press the M3 nuts into. Then comes our lid. So it also has 6 holes, which lines up with the bottom part, and it will look like this. So before building it, here's the complete circuit, and don't worry, it is very simple. So first I have pasted the screenshots of all the components which we have selected. This is the battery holder, this is the BMS, charging indicator, the switch, and our 120 watt PD board. So first we will be populating the battery pack with all the cells. So for your understanding, we will write this as B1, B2, B3, B4, and so I have designed it in a way that the cells go in alternate directions. So this will be negative, positive, negative, positive, negative, positive, negative, positive. So now we will be connecting the cells so that all the 4 cells are connected in series. So we have to make a connection here, and a last connection here. So this is a 4S 1P battery pack. So now, as you can see, this is the negative of the battery, and this is the positive of the battery. So now we will connect the BMS with the battery pack. So that will have 5 cables. One would be black and 4 of them would be red. So the first black cable will connect to the negative of the battery pack. So this will go here. The second red cable will connect in between where the positive of the first battery connects with the negative of the second battery. So it will go right here. So the third cable will go to the connection between the B2 and B3. The fourth cable will go between the connection of B3 and B4, and the final cable, fifth one, will go connect to the positive of the battery pack. Now we will add the charging indicator to the battery pack. So that is pretty simple. You simply connect the positive with the positive of the battery pack, and the negative with the negative of the battery pack. Now comes the switch. The switch has a single pole, so we will be using it in a way that it will cut the positive of the battery pack from the PD board. So we will route the positive cable from the overall positive of the battery pack and connect it to the one of the poles. The second one will go connect to our PD board. So now when we cut off the switch, the positive sides of the battery gets cut off from the PD board. Now the BMS, we can see there are two on the other side. There is one B minus and P minus. So B minus is the wire which connects to the negative of the battery pack, and P minus is the wire which we will use as the negative for our power source. So the P minus will directly connect with the PD board, and the B minus will go on and connect to the negative of the battery pack. So now we will also have the LED functionality which will glow up when we power on the power bank, which is inbuilt into the switch. So here the positive and the negative will also be connected to our power source. We want the switch to turn on when the circuit is complete to the PD board itself. So for that we will connect the positive to this side of the switch. Make sure it is this side, not the other side, because if we connect it to this the other pole, it will always be glowing because it's directly connected to the battery pack. So we want to connect it to the side where the wire is going to the PD board, and the negative will go to the overall negative of the battery. So this is the complete circuit for our power bank. I know the diagram now looks quite complicated, but if you go step by step, it's pretty simple. There are not many components, and I feel anyone can make this if they follow this step by step. So this is our completely power bank, as you can see. So here I have already installed everything and I have wired everything, but I'll just quickly once again explain it to you. So these are the 4 cells which we have in the holders. This is the battery indicator. As you can see, right now it is fully charged. This is the BMS board. This is the switch which lights on when I power it on. And this is our PD board. So I've already inserted the M3 threaded inserts also here, here, here and here. So now this is the lid part. I've covered it with a vinyl wrap, as you can see, and this will sit perfectly here. So I will now screw it back on. So this is our final power bank, as you can see. I've also added rubber feet to the bottom of it so that it doesn't make a sound and doesn't scratch the table when it's kept down. Overall, it's pretty compact for what it can do, and you can see if you press this button, we see that it is fully charged, and the same port we can use both to discharge and charge the power bank. So our charging will also happen from this port and our discharging will also happen from this port. So now we will test whether or not it can do 120 watts. So for that we will use this USB-C power meter. This I also got from Amazon. I'll give the link to it. So I'll put this into the USB-C port. Now not many products can draw power of 120 watts. I will be using my USB Type-C soldering iron to do it. So if I open, just keep it here for now. So we'll use a Type-C to Type-C cable. We'll connect it here. We'll connect it here. So now I've turned it on. This also got on. As you can see, right now it is drawing 20 volts at 0 amps because it's just turned on. Once I turn it on, it will draw the complete current, and it will heat up. So you see. So as promised in the start of the video, now I will be showing you how to use the same circuit as a DC power source. So for that we will be using a DP-DT switch. So it's a double pole, double throw switch. And now the connection will be very simple. So instead of connecting the BMS to the PD board, we will remove this connection and we will connect this negative to the center of the switch, and this positive will go to the overall positive of the battery. This side, The negative side will be connected to the negative of the power PD board and positive to the positive side. These two will be our outputs, positive and negative. So here we will get the same voltage as the battery pack. If we put it the switch into the other side, the output will be disconnected, and now it will be connected to the PD board, so we can power it up and charge it through a USB type C port. So now let us understand the full cost of the system. So our PD board was costed around 51599. All the numbers will be in INR. Plus our BMS was 629. Plus the batteries were 366 per piece, so it will be 366 into 4. Plus the battery holder was 75, so it is 75 into 2. Plus the indicator was 129 rupees. The switch was 243 rupees. The heat sinks, which are optional, was 189. You can add 200 rupees for shipping. So that totals around to 4,603 rupees. Also, we will add the PLA use. So you can use, so the case was built in approximately to, let's say, 150 grams of filament. So right now the rate of 1 kg of filament is good quality filament is 800 rupees. So we can consider 0.8 into 150. So that includes the cost of the filament as well. So 4723. So in this price, I am pretty sure you can not buy any power bank which will support up to 120 watts of power. Whether you can check any marketplace, Amazon, Flipkart, whatever, you will not find a solution like this with this high power capacity. Also, for my international audience, this will result around to divide, if we divide it by 90, which is the current INR to USD conversion rate, that gives the cost of $52.47. But as I will, the international links which I will be sharing to you, they are from AliExpress, and the same parts at AliExpress are way cheaper. So you can expect the actual cost to be less by somewhere around 40%. So it will actually cost you around $31.5. So now I will quickly explain you the overall specifications of this power bank. So we have a 4S 1P configuration, which simply means there are 4 cells in series and one row of them in parallel. So these cells are rated capacity 3400 mAh with a discharge rating of 3C, which simply means we can discharge it at 3 into the capacity in amp hours, which is equal to 11.2 amps. So our power bank can give a max of 11.2 amps, and this 18650 cells lithium ion have a nominal voltage of 3.7 volts. So that gives, and 4 of them in series, as we have 4S, so it will become 3.7 into 4, which is equal to 14.8 volts. So now we have a nominal wattage as 14.8 volts into the max amp draw, which is equal to 165.76 watts. So our power bank can give a theoretical um, power of 165 watts, and we will be only be utilizing a max of 120 watts through our two-way PT board. Two-way PD board. Also, I explained you how you can use this power bank circuit as a DC power source for any of your DIY projects. You can check out my earlier video on how to convert a old home theater into a Bluetooth boombox, and you can use the same circuit inside in conjunction to that boombox system, and you can make it portable and you can carry it anywhere you want. Thank you.